In this lesson, we are going to look into plane and plane and plane. That is, we are going to look into the case of three planes. For any three planes, there are only 5 possible scenarios. Firstly, the three planes meet at a unique point like this. These three planes meet at a unique point, shown in figure 1 here. Second possibility is the three planes meet along a line, the line of intersection of the three planes. A third possibility is the three planes are parallel and distinct from each other, right? They're parallel to each other and they're distinct. And in this case, obviously, the three planes don't meet. In the fourth scenario, two planes are parallel, but the third is not parallel to the first two. Notwithstanding that this third plane and this plane do meet here, and this plane and this yellow plane do meet here, this scenario is not deemed to be the case where the three planes meet, because to say that three planes meet, they must meet all together, like this at one single point, or like this on a line. So in this scenario, this is not counted as the planes having met or intersected. Okay, this is not counted. And then the fifth scenario shown in figure 5, where the planes are orientated like this. So likewise, these two planes meet here, these two planes meet here, and these two planes do meet here. So notwithstanding that pairwise they do meet, again this case, right, is not counted as that three planes intersected at common points. It's not counted. This don't have, because as I said, to say that three planes intersected, it must intersect at a common point like this, the three of them meet together, or like this. So let's look at scenario number 1 more carefully. If three planes do meet at a point, how would you know? If three planes do meet at a point, what you can do is you simply solve these three equations simultaneously. And if they do meet at a point, you will find that in solving these three equations, you will actually get one set of answer for x, y, and z. X, y, and z. That means one unique solution for x, y, and z. Then you will know that these three planes actually meet at a single point. In the second scenario, right? What if three planes meet along a line? How would you know? Here you have equation of plane 1, equation of plane 2, and equation of plane 3. How many equations are there? It looks like there are 3. However, you find that actually it's not 3. There are actually only 2 equations. So why are there only 2 equations? Because if you were to do this, you take negative 2 times the second equation, you try yourself again, take negative 2 times the second equation, and you subtract the first equation. You take this whole thing, it times 2, and you minus the first equation. You will notice that if you take minus 2 times this, and you subtract away the first equation, you get x. Minus 2 times this, minus 2 give you minus 6. Minus 2 times this, which is plus positive 2, minus 2 gives you 4. Minus 2 times this is a minus 10. Minus 2 will give you a minus 8. So you will realize that although it looks like there are 3 equations, but actually the third equation is redundant. Why is it redundant? Because it could be obtained from the first 2. So that instead of having 3 equations, you really only have 2. There are just 2 equations. Alright, so in the case where three planes do meet along a line, and you are interested to find the line of intersection of these three planes, what would you do? Remember, you could just go back to the earlier part of the notes wherein we look into the line of intersection of two planes. You just need to solve the first two equations for the line of intersection the way we did earlier. How about the third scenarios? How would you know that it is the third scenario? How would you know? As you guess it, you just have to check all the normal vectors. The normal vector A1, B1, C1 compared with A2, B2, C2 compared with A3, B3, C3. And what do you hope to see? If the three normal vectors are parallel to each other, then the three planes are parallel to each other. When three planes are parallel to each other, potentially there could be three distinct planes like what you see here, or potentially this plane could be an incident plane of this, which means this plane and this plane are the one and same plane. It is potentially possible. And that happens if you can reduce the equation 1 to become equation 2. If one equation can be reduced to become the second equation, then such a scenario is described as incident planes. It is potentially possible for all the three planes to be actually incident planes. That means one overlaying the other. And the three planes, if you like to insist, they are like three and one plane, three and the same plane rather, okay? Three and the same plane. If all the equation can be reduced to the one same equation, then these three planes are like three incident planes and they actually overlay each other. And in such a scenario, if you want to insist, you can say that they actually meet along a plane. But something happen, in tests and quizzes something happen, but I'm just telling you that it is potentially possible that if the three planes are actually three incident planes, or if you insist three and the same plane, then they actually meet throughout the whole plane. Right? And the fourth scenario, how would you know that it is the fourth scenario? Simply check by checking for what? Just check if there are two planes which are parallel and the third plane is not. Right? Just check whether or not, say maybe the normal vector of the first plane, you compare with the second normal vector, or you compare with the third normal vector. If you do notice that two of them are parallel and the third one is not, then you know that it is scenario number 4. Of course, there again, these two planes could have been incident planes, and this happens, as I said, when one equation can be reduced to the other, so they are the same and one plane, and then the third plane actually therefore meets so-called the common first two planes, in this case along a line. Alright, okay. So if that were the case, right, if the first two planes were to be so-called incident planes, right, if, then this could then be just two planes, the scenario of so-called two planes, right? But if the first two planes are parallel and they are distinct like this, then the scenario is exactly scenario 4. And again, we say, if it's scenario 4 just like this, then the planes actually don't meet at all. Let us now look at the fifth scenario, the case of the infinite triangular prism. So first and foremost, you want to check that this equation or this plane pi 1 is not parallel to pi 2 by checking that the normal vector of the first plane is not parallel to the second plane. You also want to be sure that pi 1 is not parallel to pi 3 by checking for the normal vector against the normal vector. They are not parallel. And then pi 2 and pi 3, check for the normal vector against the other normal vector as long as they're not parallel. That means to say pairwise, you do not have any parallel planes. By so checking, right? By so checking, you have actually so-called be able to rule out the third or the fourth scenario. The third wherein 3 planes are parallel, the fourth wherein 2 of them are parallel, and the third is not. So once you have done this checking and therefore rule out the third and fourth scenario, the next thing that you want to do is to try to solve these 3 equations. If upon trying to solve these 3 equations, you get no solution, then your conclusion is it must be this case, the case of an infinite triangular prism. Moving on, we want to learn how we can manage 3 planes in a given question. If you are given 3 planes in a question, the first thing you want to do is to try to rule out the possibility of the third and the fourth scenario. How do you do so? You just check whether or not this plane and this plane, are they parallel? This and this, are they parallel? This and this, are they parallel? So once you have checked and confirmed by checking the normal vectors, you have checked and confirmed that there isn't a case of pairwise parallel or 3 planes being parallel, then you have managed to rule out the third and the fourth scenario. After you have done this part, the next thing is you want to do this. You want to just ignore the third equation for a moment and look just at the first 2. And because the first 2 are not parallel to each other, you can always do like what we have done previously in the earlier part of the notes. We can actually work out the intersecting line between these first 2 planes using methods we have learned in the earlier part of the notes. Right, once you have worked out the intersecting line between these 2 planes, you can then study how this intersecting line interacts with the third plane. Now this is actually the recommended approach. Of course, there are other possible approaches, but we would like you to adopt this, and that is to just ignore the third equation for a moment, solve the first 2 for the intersecting line, and then study how this line interacts with this third plane. This is the recommended approach. So we are saying to you, for 3 planes, deal with the first 2 planes first, followed by the intersecting line of the first 2 planes, then and the third plane. So if you do like what we have just told you, that is, firstly you confirm that this is the case. All right, confirm this case. So that will rule out the third and the fourth scenario. Then you work out the intersecting line of the first 2 planes. Let's call this line L, right? Call this line L, and then you will try to study the interaction between this line L, which is found from the first 2 planes. This line L is the intersecting line of the first 2 planes. We then study how this line interacts with the third plane, and there are altogether 3 possibilities. One possibility is this line lies on the third plane. If this line L lies on the third plane, then you have the scenario wherein the 3 planes actually meet along the line L, and that's actually scenario 2. If the line meets the third plane just once, right? If the line L meets the third plane just once, then the 3 planes are said to meet at only one point, and that is scenario 1. If this line L doesn't meet the third plane at all, bearing in mind that this line L is the line of intersection of the first 2 planes, which means it carries with it all the common points of the first 2 planes. If these common points of the first 2 planes don't meet the third plane at all, that means the 3 planes don't meet, and that's scenario number 5. I have some hand sketches to show you more vividly, I hope, of these 3 possibilities. So firstly, if this is the first plane and this is the second plane, right? you can work out the intersecting line of the first two planes. If this line L lies on the third plane, right? Lies on the third plane, can you see this is the third plane? Then you have the scenario 2, wherein these three planes, 1, 2, and 3, right? They actually meet along this red line. This is scenario number 2. On the other hand, if you work out the intersecting line between the first two planes, and this intersecting line is not parallel to the third plane and hence meets the third plane at a single point, then these three planes 1, 2, and 3 are said to meet at that unique point here. And that is scenario number 1. And lastly, if the first two planes meet along a line L, and this line L is parallel to the third plane, I've shaded the third plane on top. It's just like serve like a cover kind of thing, no? Right, this is the third plane, the green shaded thing on top. So if this intersecting line of the first two planes, this line doesn't meet the third plane at all, then you say that of course these three planes don't meet, and you actually have the case of scenario 5 where the three planes actually form an infinite triangular prism. And with this, that brings to the end of our discussion of three planes. You can now move on to your tutorial, part 2.